Play in the brain. Connections, implications, and applications of neuroscience and play on early childhood education. Presented by Jennifer Mesman. This presentation provides a systematic review of current research involving neuroscience, play, and child development. Connections between play and brain development. The role of play in cognitive, language, social, emotional, and physical development. And suggestions for bringing brain research and educational practice closer together are included. 90% of a child's brain development happens before the age 5. Source: Harvard Center for the Developing Child. Since the 1960s, the growing body of research on the human brain and its role in child development has challenged the notion of fixed intelligence once held by many professionals, including biologists, neuroscientists, psychologists, pediatricians, and educators. Although neurodevelopment and intelligence used to be considered as fixed by our genes, we now know genetics and experience work together to form the child. Both animal and human studies support emerging theories suggesting infancy and early childhood periods to be the most advantageous for development because it is during these periods when the brain is most capable of adapting to environmental stimulations. High-tech brain imaging focuses on 3 elements of brain organization and operation: chemical composition, electrical transmission in magnetic fields, distribution of blood through the brain. CAT scans and MRIs create graphic 3D images of the brain's anatomy. Fast MRI make it possible to observe brain activity on a television during a subject's cognitive activity. PET is a non-invasive technique that allows tracing of brain energy as regions of the brain are activated by monitoring blood flow and other chemical functions. Organization of the brain. The brain's function stems from the activities of several billion neurons and trillions of synapses that transmit electrochemical signals. Every neuron has an axon, and each axon contains many dendrites. A synapse is formed when the axon of one neuron connects with the dendrite of another neuron. Neurotransmitters are required for electrochemical transmission across these structures. As neurons expand, a baby's brain grows in volume and weight. Even though the number of synapses may increase at an impressive rate during the first 3 years, the number of neurons remains constant. By age 3, a child's brain has approximately 1,000 trillion synapses, about 2 times the number of an adult's brain, and it is about 2.5 times more active. A child's early experiences plays a crucial role in determining the brain's neural network as well as the extent of intellectual abilities. As a child develops, an intricate system of neural pathways are formed. Pathways repeatedly used are strengthened, protected, and retained into adulthood. By late adolescence, about half of the brain's synapses have been discarded through a process called synaptic pruning. Brain development is without question a use it or lose it process. Neuroplasticity. The brain's ability to continually reorganize its structure by forming new neural pathways and synapses as it processes information. Every experience structurally changes our brain by either helping new synapses to grow or pruning old ones away. The intense neurological growth in the early years enables children to be highly adaptable to a huge variety of situations. It is this rapid growth that inspires a child to explore, discover, play, and make connections between self, others, and their world. Connections between neuroscience and play. Connections scholars and scientists have found between brain development and play include: all healthy young mammals play. Play guides neural structures, creating increasingly complex neural structures, which encourage ever more complex play. Play helps young animals and humans practice skills they will need later in life. Human infants and young children specifically practice motor, language, and negotiation skills. Play is elemental for healthy development. Quote, early childhood experience exert a dramatic, precise impact on the wiring of the neural circuits, and the formation and selecting out or pruning of synapses coincides with the emergence of various developmental activities. Play deprivation results in atypical, often violent behavior. Cognitive development. The majority of the brain's neurons are allocated to identifying, analyzing, and solving problems. They decide how to respond by interpreting sensory information and then comparing it to recalled information. Comparably, the number of neurons involved in direct sensory interactions with the environment or with regulating of basic body processes is relatively small. Young children's brain development and cognitive achievements are well disguised to most. In fact, the only people able to see physical evidence of the relative consequences of environmental stimulation or neglect are neuroscientists via brain scans, which is why the casual observer often misses the profound relationship between brain development, cognitive achievement, and the endless games the very young play. Language development. The brains of typical children are programmed at birth to learn any language. As early as 6 months, infants become attuned to the sounds of their native language. As early as 11 months, infants begin losing the ability to differentiate between phonetic sounds they have not heard, those spoken in other languages different from their native. There is a strong correlation between parents talking with their babies and vocabulary development. Reciprocal talk, when parents talk and babies listen and then make primitive sounds or reactions, helps strengthen the neural pathways critical to language development. Quote, the number of words an infant hears each day is the single most important predictor of later intelligence, school success, and social competence. Current brain research suggests there can actually be too little stimulation and too much stimulation. Simply filling a child with excessive information or scheduling too many activities may lead to overstimulation. Language development is best supported through dynamic communication in a warm, emotional context with a caring adult, not endless, mindless television or video games. Adding an emotional context to information makes it immensely more powerful in stimulating neural development versus information alone. Indeed, tone of voice can even make a difference. Social development. Quote, the single best childhood predictor of adult adaptation is not IQ, not school grades, not classroom behavior, but rather the adequacy with which the child gets along with others. Hartup, 1992. Socialization is the only way children can truly learn social skills. Imaginative or make-believe play is a powerful medium for socialization because it simplifies many aspects of our complicated world, making them more manageable and comprehensible. It is this kind of play that helps children get along with our increasingly complex world by supporting cooperating, sharing, negotiating, and problem-solving skill development. Emotional development. The fundamental pathways that control emotion develop before birth. Post-birth, when parents participate in serve and return, they are reinforcing the brain's chemical and electrical signals, helping to, quote, wire the brain's calm-down circuit. Extreme or repeated trauma overloads the brain circuits with the neurochemical cortisol, which can be the beginning of a vicious cycle because the more frequently they are stimulated, the easier and more likely they are to react. Thus, repeated stress can truly change a brain structure, impairing one's ability to handle stressful situations. Quote, play is the language of children. Where adults are able to talk things out, children use play to work through their fears and traumatic experiences. Children lacking the language or cognitive abilities to comprehend and deal with personal trauma experiences or resolve conflicts can work through them through play because of its therapeutic qualities. Play gives concrete form and expression to children's inner world. A major function of play is the changing of what may be unmanageable in reality to manageable situations through symbolic representation. Implications of neuroscience, play, and child development. Young children need secure attachment and bonding with parents, so spend lots of time playing together. Positive activity supports healthy brain development, so be accepting, playful, warm, and nurturing. Be mindful of a child's moral development. Many games offer moral implications, including taking turns, sharing objects, and listening to others. It is important to challenge children, but make sure expectations are not far beyond ability range. Remember the phrase, difficult but doable. Touch has health and therapeutic benefits. Infants should be hugged, rocked, patted, and cuddled. Toddlers and older children should engage in gentler wrestling, tugging, tossing, and chasing games. These are vital in programming motor abilities and reinforcing social emotional behaviors. Talk to children even before they are able to talk back. Remember, this is called serve and return, which helps build the baby's brain. Listen to children. To best stimulate neural development, early language needs to be personal and related to ongoing situations. Introduce music and art early. Instead of watching television, choose play, art, music, and the outdoors. These activities produce long-term changes in neural structures, which influence thinking and reasoning abilities. Provide lots of simple and raw materials like blocks, beads, sand, water, pots and pans, dress-up clothes, and other simple age-appropriate tools. Do your best to protect children from stress and trauma. The brain is very vulnerable to stress and trauma, and the effects of extended exposure on brain development can be permanent. Pay careful attention to avoid overstimulating children with too many toys, too much meaningless talk, too much noise, or too much activity. Provide ample time and space for exploration. Read, sing, and play games with children every single day. Remember, when given appropriate care and therapy, the brain has an incredible ability to compensate and even regenerate. Keep this in mind when dealing with children having birth defects, developmental disorders, or suffering from some other traumatic experience. Applications of neuroscience, play, and early childhood education. The brain-enriched classroom. Emotion plus attention equals learning. Children emotionally invested are more likely to stay interested and connected to the learning process. Supporting learning for all children. For a classroom to be brain compatible, it must be able to grow new synaptic connections between brain cells with few, if any, loss of existing connections. Student expression and choice allow for individual growth. Students need to be actively responsible for their learning in order to engage multiple regions of the brain simultaneously. Effective teachers encourage students to make discoveries in a well-planned environment, thus supporting brain development and student autonomy. A child-centered learning environment which stimulates the child's interests also optimizes the brain's ability to understand, absorb, and retain information. Teachers must be attuned to the individual needs and stress levels of the students. As advocates for student empowerment, teachers need to create learning environments that excite, stimulate, and challenge the brain. Components of a learning environment which supports optimal brain development. Learning opportunities must include active sensory stimulating areas, sparking curiosity and imagination, coupled with student autonomy to interact and experiment with their surroundings. Students have control of their learning, and the teacher's role is one of facilitator. Neurologically speaking, feelings of excitement and novelty generates the neurotransmitter dopamine, giving feelings of well-being to the student. These emotions are what drive attention, the ability to remain connected, focused, and it is this attention that drives learning. Teachers are aware of the emotion-learning connection will better capture and maintain their students' attention by including them in the instruction process. Students given extensive opportunities to express and engage in their learning are more likely to connect and apply their learning to the outer world. The more connections the student makes, the better their problem-solving skills will become. Components of an active learning environment supporting optimal brain development. The physical arrangement of the furniture, tables and chairs, centers, libraries, and even lighting to attract child interest. Workspaces for individual, small group, and large group meetings. Manipulative materials to intrigue natural curiosity. Ample spaces and large blocks of time to allow children to explore, role play, and experiment. Compassionate and caring educators who model positive interactions and a love of learning. Educator understanding and application of developmentally appropriate practices to guide the actions and interactions among teachers and students. Koppel and Bredekamp said in their book, Developmentally Appropriate Practices, a teacher's moment-by-moment actions and interactions with children are the most powerful determinant of learning outcomes and development. Curriculum is very important, but what the teacher does is paramount. Next, we'll be connecting theory to practice, using conditions of literacy learning, developmentally appropriate practices, and neuroscience. Immersing a young child in an environment that stimulates the senses and has an emotional element signals the brain's neurological networks to pay attention. These rich learning environments filled with age-appropriate literature, materials to manipulate, and interest-piquing questions will lead to great learning opportunities. Children need the opportunity to make choices concerning daily activities and learning opportunities. Freedom to choose is vital to building a non-threatening environment. The amygdala responds to stress, real or perceived, by releasing a host of hormones and neurotransmitters that inhibit rational thought. Children need to feel safe to be able to learn from mistakes and celebrate accomplishments. Children learn best in positive environments where they make decisions about their own thinking and learning. This ability to choose provides immediate buy-in from the student. The best model of learning for young children is play. It is open-ended and is consistent with both individual differences and unique talents. Children entrusted to caring educators that accept the whole child and encourage the natural learning progression will feel confident, competent, and more willing to learn. These tables include information on the NAEYC's positions of developmentally appropriate practice, Camborne's 8 literacy conditions of learning, what brain-based research suggests about how the brain learns best, and gives additional information for classroom practices. I will not be reading all of them here. Please revisit at your leisure. During the first years of life, it is playful activity, not direct instruction, seclusion, deprivation, or abuse, that makes a positive difference on brain development and subsequent human functioning. Children who don't play much or are rarely touched develop brains 20 to 30% smaller than normal for their age. Nash, 1997. This video by Dr. Lois Holtzman does a great job of explaining how and why we should play and its impact on us growing and developing. Remember, immersing young children in a highly motivating environment that has been purposefully organized to promote active engagement will likely engage the prefrontal cortex of the brain, which helps to solidify learning. Part of this rich learning environment is the teachers observing and documenting the students' thinking and doing on a continuous basis to plan future opportunities. Key points for creating a rich learning environment: the physical setting is stimulating yet non-threatening, large blocks of time for exploration, children's choice over what they engage with and are considered the experts, hands-on learning with real events and experiments to read and write about, open dialogue between the teacher and students the students with each other, integration of content areas with opportunities for meaningful problem solving, and assessment strategies that are an authentic product of student activities leading to senses of accomplishment, not stress. Some critical questions. How does the information from this presentation on neuroscience and learning mesh with your personal understandings? If the information is new, how will it affect your professional practice? If you are already familiar with brain research, did this presentation add or change your prior knowledge in any way? As an advocate for play in early childhood education settings, are the connections presented between brain research and play important? How could this information be used to help others understand the important role play has on early childhood education? These are some additional articles that you might find informative, as well as some books. Thank you.